All right, so let's get into this. This is the spring 2024 exam for MA261. What happened to my name? Okay, whatever, doesn't exist. Let's go on. First question. According to Green's theorem, which of the following line integrals is not equal to the area of the region enclosed by a simple curve C oriented counterclockwise? Okay, so we know that Green's theorem is equal to the partial derivative of x at g minus the partial derivative of y fx. So in this case, what they want is, when you use Green's theorem, this volume should equal out to 1. So gx minus fy should equal to 1. So let's check these points here. So in this case, it will be 1/5 times 6 minus 1. So that'll be 1/5 times 5, which is 1. So it can't be A. And this will be 1/5 times 2 minus -3. That'd be 5 times 1/5 equal to 1. Can't be B. 1/5, this would be 1 minus -4, which would be 1/5 times 5, which is 1 again. Can't be C. For D, it would be 1/5, 7 minus 2, which would be 1/5 times 5, which is equal to 1. So it can't be D either, so it has to be E, but let's check it anyways. This will be -3 minus 2, which is equal to -5 times 1/5, which is -1, which is not what we want, which is why in this case, the answer for this one, oopsie daisy, let me just erase all those. The answer for this one will in fact be E. Okay, number 2. Given the force field F equals the vector x, y, z, find the work required to move an object on the helix r of t equals 2 cosine t, 2 sine t, and t over 2 pi from 0 to 2 pi. Okay, so for this one, we simply got to find the integral of f times r prime of t dt. So let's start this by finding r prime first. That would be -2 sine of t, 2 cosine t, and this will just be 1 over 2 pi. Now let's find f of r of t, which in this case we just plug in for x, which would be 2 cosine t, plug in for y, 2 sine t, plug in for z, which would be t over 2 pi. Now we just have to dot both of these, so you get -4 cosine t sine t plus these two would be 4 cosine t sine t. And these would be 2 over 4 pi squared. Okay, so these two cancel out. We just get left with the integral from, they already gave us the bounds, 0 to 2 pi of t over 4 pi squared dt. So let's do this. So this will simply become t squared over 8 pi squared from 0 to 2 pi. Once we evaluate that, we just get 4 pi squared over 8 pi squared. The pi squares will cancel out, which just leaves you with 1/2, which in this case, 1/2 is our answer, D. Okay, number 3. Find volume of the solid region bounded by two surfaces, z equals x squared plus y squared minus 9, and z equals -2 times the value of x squared plus y squared. They say use cylindrical coordinates. I'm just going to use polar coordinates. This will be z is equal to r squared minus 9. This will become z is equal to -2 r squared. So we set these equal to each other. R squared minus 9 is equal to -2 r squared, which means that 3r squared is equal to 9. Means that r squared is equal to 9 over 3, which is 3. R is equal to the square root of 3. That is our radius. Now, for theta, these are just two circles. So we know that our theta will just be from 0 to 2 pi, while our r is from 0 to square root of 3. Now, how do we find our f value? Well, that'll just be z, the top z, minus the bottom z. So which one's the top, which one's the bottom? That's pretty easy. We just plug in a value. So we know that this z is equal to r squared minus 9. This z is equal to, well, I guess we can write it like this, x squared plus y squared minus 9. This z is equal to negative 2, x squared plus y squared. You can just plug in, for example, 0, 0. This one will produce the number negative 9. This one will produce the number 0. Now, so from this, we would know that in this case, this is the top one. So we would evaluate it by going negative 2 r squared minus r squared minus 9, which in this case would get us negative 3 r squared plus 9. Okay, so now we have our bounds, negative 3 r squared plus 9 r, oops, let me write that, r dr d theta. So we can evaluate this now. This will get us, simply by evaluating this, we start off with 3r cubed plus 9r, and that will equal out to negative 3 over 4 r to the 4th plus 9 over 2 r squared from 0 to square root of 3. Once we plug those in, we get negative 3 over 4 times square root of 3 to the 4th will be 9 plus 9 over 2 square root of 3 squared, will just be 3. So you get negative 27 over 4 plus 27 over 2. You can turn this into a 54 over 4, which gets you positive 27 over 4. So in this case, positive 27 over 4. And now we just have to evaluate that from 0 to 2 pi, 27 over 4 d theta, which would simply get you 2 pi times 27 over 4. I'm just going to take those two out by getting 27 pi, and the bottom becomes a 2. So 27 pi over 2, which is answer choice C, which in this case is our correct answer. Okay, moving on to number 4. Compute this simple double integral. Now you might be wondering, how do we get through that? Well, the little trick we're going to use is by simply taking it out. We can instead rewrite this as square root of x times square root of y. This will stay as dx dy, and now we can just evaluate it like this. Square root of y will come out, square root of x will stay in, 0 to 4, dx, we simply get x 3 over 2, 2 over 3, from 0 to 4, which gets us 2 over 3 times 4, 3 over 2 minus 0, 3 over 2. Obviously, this doesn't matter. Y to the power of, whoopsie-daisy, I did not draw that error well. Y to the power of 3/2 is simply, in this case, 8. This would mean equals to 8, which just gets us 16 over 3. So now we got to evaluate 16 times our new integral, which is 0 to 1. Square root of y is now in. So that should be over 3. So we just get the same thing, 2 over 3, y to the power of 3/2 from 0 to 1, which just produces 3 over 2. Once we multiply that by 16 over 3, we just get 32 over 9, which in this case is answer choice A, which is our answer for number 4. Okay, so moving on to number 5, compute this integral. Okay, so how do we do this? Well, we're going to convert this to polar coordinates. Polar coordinates. Yep. So this becomes e to the power of r squared. If we have this, we know that x is equal to the square root of y minus 9 squared, which means that x squared is equal to 9 minus y squared. So x squared plus y squared is equal to 9, which means that our radius is just 3. Okay, so our bound's already set at this point. It's from 0 to 3 for a radius, and we already know that since it's a circle, it'll be from 0 to 2 pi. This is e to the power of r squared times r dr d theta. So if we do this, we can take the u substitution as r squared. The du will be 2r, so you get left with 1/2 e to u. If we plug in the 3 to r squared, you get 9. If we plug in the 0, you get 0. So you get 1/2 e to the power of 9 minus e to the power of 0. Just gets you 1/2 e9 minus 1. Now we evaluate this. 1/2 e to the power of 9 minus 1 from 0 to 2 pi d theta. So you just multiply everything by 2 pi. So you get 2 pi over 2 from e to the power of 9 minus 1, which simply gets you the, oopsie daisy, the 2's cancel out, and you just get left with a pi times the sum, I guess difference, of e9 minus 1, e to the 9th minus 1, which in this case is answer choice A, which is our answer for number 5. Okay, number 6. Which of the following integrals represent the volume of the solid in the first octant bounded by the plane 3x plus 2y plus 6z equals 12? So the first step to this is looking at our integral. So we're going to go from z to x to y. So let's do z first. So put everything to the side except for z. You get 12 minus 3x minus 2y. Divide everything by 6. You get z is equal to 2 minus x over 2 minus y over 3. Okay, so if we look at these values that are constant with every single question, every single bound, we also know that z in this case is just equal to 0. So now, if our next thing is x, we just do the same thing. Now we know that x over 2 is equal to 2 minus y over 3. If we multiply everything by 2, you get x is equal to 4 minus 2/3 y. So we can already start eliminating some answers. We know it won't be this one because it's y minus 6. No, it can't be this one because it's 4 minus only y over 3rd. Can't be e either. So now we're just left with the answer choices A and B. So in this case, we don't need to go any further, but I will. We also know it's equal to 0. So in this case, 2 over 3y is just equal to 4, which means that y is equal to 4 times 3 over 2, which in this case is 12 over 2, which is 6. But both of the answer choices already have a 6, so you don't even really need to know that. These two are also the same. So actually, we just need to go back and check our z. So we know that our z is 2 minus x half, minus 1/2 x minus 1/3 y. This one has a 3. This one has a 2 that we want. So we know the answer choice for this one is B. And number 6 is B. Moving on to number 7. At which points on the curve x squared plus y squared equals 4 does the function f of xy equals 4x squared plus 10y squared achieve an absolute maximum? This is a Lagrange question, but I gotta warn you, it's kind of weird. So let's do what we normally do. Take the gradient at f, which in this case will be 8x comma 20y. Sorry, I had to wring out my wrist. The gradient at g will be 2x 2y. So now we just do gradient of f is equal to gradient of g lambda. So 8x is equal to lambda 2x, just like 20y is equal to lambda 2y. So how am I going to solve this? Well, this is where it gets kind of weird. What I'm going to do is I'm going to say 8x minus lambda 2x is equal to 0. I'm going to take the 2x out, which leaves me with 4 minus lambda equals to 0. So in this case, we either know that x is equal to 0 or lambda is equal to 4. And now we have to plug these back in. So if we say x, when x is equal to 0, then we know that 0 plus y squared is equal to 4. So y is equal to plus or minus 2, which means for this one, our critical points are at 0, 2, and 0, negative 2. If lambda is equal to 4, then in this case, we can say that 20y is equal to 4, 2y. So 20y is equal to 8y. If we subtract both sides, we get 12y is equal to 0, so y is equal to 0. So when y is equal to 0, know that x squared plus 0 is equal to 4, which means that x is equal to plus or minus 2. So in this case, our critical points will be at 2, 0, and negative 2, 0. So there are critical points. We now have to test f. So f of 0, 2 will be equal to, in this case, actually, let me just, let me write this out. It'll be 4x squared plus 10x squared, which is equal to, oh, that's it. Oh, well, not 10x squared, 10y squared. So in this case, it'll be equal to 0 plus 10 times 4, which is 40. At f of 0, negative 2, we get 0 plus 10 times 4 again, which is 40. At f of 2, 0, we get 4 times 4 plus 10 times 0, which is just 16. Then f of negative 2, 0, we also just get 4 times 4 plus 0, which is 16. So our two maxes occur at the points 0, 2, and 0, negative 2. In that case, our answers will be A. And that is our answer for number 7. Okay, number 8. Let f of x, y, z equal to x to the 4th plus x squared plus z to the 5th, and g of x, y, z equals to x squared plus 3y plus 2z, and suppose the gradient of f at 1, 1, negative 1 is perpendicular, I guess you can also say orthogonal, to the gradient of g at ABC. Then, now they want us to find A. So what we got to do is we got to take the gradient of both of them first off. In this case, this will be 4x cubed plus 2y plus 5z to the 4th. And the gradient at g would be equal to 2x, 3, and 2. So now we got to find the gradient of f at 1, 1, negative 1. That's pretty simple. That's just 4 times 1 cubed plus 2 times 1, sorry, not plus, comma, and then 5 times 1 to the 4th, negative 1 to the 4th, which will get us the answer 4, 2, and 5. Okay, so you might be wondering, what makes vectors perpendicular? Well, that's if the dot product equals 0. So if I take the gradient of f and dot it with g, we should get 0. So in this case, 4, 2, 5 times this vector will equal to 0. Now, what is this vector? Well, you simply have to plug in A, B, C. If you see, for the gradient of g, 3 and 2 will be constants because there's not There's no y, there's no z here, so it doesn't really matter. But with with the x component, there is an x, so we're going to plug in an a there. So now we just multiply this out. It'll be 8a plus 6 plus 10 equal to 0. So 8a is equal to, this will be a 16. So negative 16. In this case, a will just be equal to negative 2, which is our answer A, which is the answer for 8. Cool. I hope that wasn't too confusing. That was number 8. Moving on to number 9. Given that the f vector 7 minus 4y, comma, 2y minus 4x is conservative, so this is a conservative vector field, and f is equal to the gradient phi, or phi, evaluate this line integral where the curve c is parametrized as r of t equals et cosine t and e to the t cosine t from 0 to 2 pi. Okay, so what do we have to do for this one? It's actually not as bad as you might think. What we just have to do for this one is we have to take this as a potential function. There's two methods. You can, one, take potential function, then use the fundamental theorem of line integrals. Or two, you can also just do fr of t times r prime of t. But I don't know if I'd recommend doing that. You'd be in a world of hurt, because that is a lot of math. Okay, so let's find this, shall we? Okay, so the integral of f at x would be equal to 7x minus 4xy plus a of y. In this case, you take the derivative of d, take the derivative at y, which will get you 0 plus 4x plus a prime of y, which is equal to their g, which is equal to 2y minus 4x. So this means a prime of y is equal to, hold on a second, I think I did something wrong. Oh, this should be a negative. Sorry. Will be equal to 2y. So now we just take the integral of that at y. So a prime of y will be equal to y squared. So now our potential function is just 7x minus 4xy plus y squared. And we have to convert these to t, so we gotta plug in r of t, which in this case, we gotta plug in this x value, this y value, which gets us, 7e to the t sine of t minus 4et sine of t e to the t cosine t plus et cosine t squared. Okay, so that's still a lot, but honestly, this method will produce the answer a lot faster than the other one. So now we just gotta plug in 2 pi minus 0. So when you plug that in, you get 7e 2 pi sine of 2 pi. So this already is a 0, minus 4e to the 2 pi sine of 2 pi again. So that's another 0. So in this case, all you get left with is e to the 2 pi cosine of 2 pi, which in this case, that's all squared as well, will get you e2 pi squared, which is just e to the 4, whoopsie daisy. I'm really screwing this up. E to the 4 pi. Okay, so that's our first one. Now let's solve the other one, the potential function at 0, which produces us 7e to the 0 sine of 0, which is again nothing, minus 4e to the 0 sine of 0, which is again nothing, plus e to the 0 cosine of 0 all squared, which just gets you, which just gets you 1 squared, which is just 1. So in the answer, the potential function at 2 pi minus the potential function at 0 is just e to the power of 4 pi minus 1, which in this case is the answer choice E, which is our correct answer choice for number 9. Okay, suppose f of x, y, z is equal to x times y squared times z cubed. Then you got to find the divergence of the gradient of f at 2, -1, 1. So the divergence, remember, is the partial derivative of x at f plus the partial derivative of y at g plus the partial derivative of z at h. So we got to find the gradient of f, which in this case will be y squared z cubed 2x times y z cubed still. And then for this one, it will be 3x times y squared times z cubed. And now, simply find the divergence. So the divergence of the gradient of f. In this case, this will be a 0 because there are no x's. This will be a 2x times z cubed. And this will be a 6xy squared times the z. Cool. Okay, and now we have to find this at the point 2, -1, 1. So in this case, this would just be 0 plus, 0. Oh, whoopsie daisy. I should have written this out better. This is not a vector. Anyways, you'll just get 2, plug in a 2, plug in a y. Remember to just plug your stuff in. 2, -1 cubed, 1, which simply ends out with 4 plus 12, which is 16. In this case, 16 is C, which is our answer for number 10. Okay, number 11. Okay, this one is weird. I'm going to teach you guys through it. There are, I would say, 3 methods. Two of them are the same method that diverge off the path at the very end. And one of them is just a method that you either know or you don't know. And I think it originated kind of like in the beginning of this class, but let me teach you. So you got to find the area of the part of the plane 2x plus 5y plus z equals 10 that's in the first octant. So how am I going to start this? Well, I'm going to find the intercepts. So the x-intercept, when all these are 0, it's just 2x equals 10, which just gets you x equals 5. The y-intercept, which will be 5y equals 10, so y is just equal to 2. And then the z-intercept, well, that's just z is equal to 10. So if we were to draw this out here, you got an x at 5, a y at 2, and a z at 10. They form this triangular shape right here, which is very cool. This is only in the first octant. I'm assuming it looks a lot weirder than this. And now, what we have to do is imagine this is point P, right? This s-intercept. This is point Q. And this is point, I'm just going to say H, because I forgot what points they usually use. We got to find the vector PQ and the vector PH. I know, it's very weird. So, since we know that this will be point 5, 0, 0, this will be point 0, 2, 0, and then this will be the point 0, 0, 10. Okay, so for PQ, you just do the second point minus the first point. So you get 0 minus 5, which is -5, 2 minus 0, which is 2. 0 minus 0 is just 5. These should be vectors. Then pH, same thing. 0 minus 5 is 0. 0 minus 0 is 0. And 10 minus 0 is just 10. Now, you might be wondering, what do we do after this? Well, now you got to take the cross product of these. So that would be negative 5, 2, and 0. Negative 5, 0, and 10. So, let's do this. This will be 20 minus 0, I minus negative 50 minus 0, j plus 0 minus negative 10k, which gets you the vector ultimately 20, 50, and 10. Now, in order to find the area of this thing, now the area of this is the area of a parallelogram. In order to find this, that is a triangle. You might remember that in order to find the area of a triangle, it's 1/2 of the magnitude of the parallelogram. The magnitude of the 1/2 of the magnitude of the parallelogram. So let's find the magnitude of the parallelogram, shall we? 20 squared plus 50 squared plus 10 squared. That would be equal to the square root of 400 plus 2500 plus 100, which is the square root of 3000. Now, how I'm going to do this, I'm going to split this into 30 times 100, which gets me 10 times the square root of 30. Remember, this is all under 1/2, which gets us 5 square root of 30. Now, if they're just asking for this thing and it was just a parallelogram, you just stop right here. But since it's a triangle, the answer is 5 square root of 30. In this case, the answer is D, which is our correct answer. But there's another method you can use, and it's quite strange too, but here it is. So, in order to find this, we have to find the surface area. And in this case, the surface area is the double integral of the square root of z minus dy plus 1 dA. Now, you might be wondering, what is this? And you don't have to be very scared. Since this is the 2024 exam, this is actually a surface integral problem. That is not on our test, but I would still know how to do this for our final test because it will be very important. So, what is z at x? Well, we know that in this case, z is simply equal to 10 minus 2x minus 5y. So, the partial derivative of x at z is going to be negative 2. The partial derivative of y at z will be negative 5 plus 1 dA. Okay, so, oh wait, these are supposed to be squared. So, in this case, we get under the square root 4 minus, sorry, this is supposed to be a plus. Oh my lord, sorry, I'm really messing this up. I'm trying to teach surface integrals, and it's not even on the test. Whatever. This is going to be 4 plus 25 plus 1, which gets you the square root of 30. Now, this is where it diverges. So you now have the square root of 30, and in order to find this area, it's the square root of 30 times the area under here. You know it's a triangle, right? So if you have your triangle, and you have your x point, which is at 5, and your y point, which is at 2, you just know base times height over square root, which is just which is just 5 over 2 over 2, which just gets you 5. So 30 times 5 gets you 3 square root of, holy moly, 5 square root of 30. In this case, this also produces the correct answer. But if you want to make your life even more complicated, what you can do is instead of doing all that, you now take the double integral. of square root of 30 dy dx. So our x will go from 0 to 5. Our y will go from 0 to this line here, which is 2 minus 2 over 5x. And when you integrate all this out, you end up with 5 square root of 30. So you have three methods here. I'm gonna list them out. Method 1, area of parallelogram, magnitude cross product. The second method is surface area that transitions into square root of zx, sorry, whoops, minus square root of zx squared plus zy squared plus 1 multiplied by the area. And the third one is surface area double integral. You can use any of these three ones. I personally think that this one is the one that will be the most easy if you were really good on the first exam. This one's the best if you already learned surface integrals. And this one's the best if you really hate yourself. Number 12. Number 12 is our last question. So, number 12, compute this double integral cosine of y squared dy dx over these vertices. Okay, so I'm just going to make some of these up, right? This is at 0, 0. We can say this is 0 square root of pi over 2. This looks like square root of pi over 2. Square root of pi over 2. Yeah, this is what our triangle looks like. So, in this case, here's how we're going to do this. If you go from x to y, what you can say is that in this case, this is actually the equation y equals x, because if you take the slope, the intercept is at 0, plus, and then this will just be rise over run, square root of pi over 2 minus 0, square root of pi over 2 minus 0, which is just equal to 1, so that's x. You can also say that x is just equal to y. In this case, I'm going to say it's x is equal to y, so it goes from 0 to y. And y goes from 0 to square root of pi over 2. And we already know that our f is cosine of y squared, and this will be from dx dy. Now they want you to do dy dx, but honestly, I did it. I was like, dx dy is way easier, so I'm just going to do that. So in this case, when you compute it, you get y times cosine of y squared. That's from 0 to y. Sorry, not y squared, x squared. So you get y cosine of y squared. And now we can compute this from pi over 2. 0 to square root of pi over 2. So we take a u substitution. U is equal to y squared. Du is equal to 2y. So you get left with 1/2 cosine u from this case. 0 is still 0. And square root of pi over 2 squared is just pi over 2. dy, this simply becomes 1/2 sine of u from 0 to pi over 2, which simply gets you 1/2 sine of pi over 2 minus sine of 0. We know that sine of 0 is 0, sine of pi over 2 is 1, so you get 1/2 times 1, which is just 1/2, which is our answer B, which is the final answer for this one. Now, you might be wondering, wow, that was a really weird exam. And yes, sir, it was. It used some very strange topics, and that's because this exam, they did have surface integrals in there. But if you got through it with me and you're like, I got like pretty good, then you should feel pretty good about yourself. I hope you learned something. Remember to just look through these questions. Even though we don't have surface integrals on our exam 2, any of these other problems definitely have a good chance of showing up not in these forms, but I'll say the same questions will probably show up just with a lot of different numbers and wording. So just be ready for any of them. I hope you learned some good math today, and have a good day.